Hello class 9th. In this video you will watch the quick revision of chapter 7 triangle of NCERT. In this we'll see the basic concept and some important questions. The basics of the congruency is that any polygon overlap each other with sides, vertex, angles, then these are congruent. For example, these two congruent, see red and yellow, they are overlapping each other. So these two are congruent, but these two are not overlapping each other. So these are not congruent. Similarly, in this page you can see that these are congruent, but these are not congruent, small and bigger square. So any polygon can be congruent if they overlap each other by all respect. Two circles are congruent if the radii are same. Now listen student, in this page you can see this figure number 2, this 3 and these 4 are congruent to ABC. This is a symbol of congruent. I am writing here. These all three angles are triangles are congruent to ABC because the sides are equal. See 4.5, 4 and 5. But this figure 5, 5 and 5, these three sides are equal. So it is not matching with this ABC. So this and this are not congruent. Respective sides or respective angles for both should be equal. First criterion of the congruency of triangle, SAS congruency rule. It's very simple. Side angle side, side angle side, side angle side. You remember it should be in proper order. These triangles are congruent. But suppose the triangles are like this, side angle and this sides and this angles equal, suppose. So these are not congruent because it should be in proper order, same order. Side, so left side, angle in between the two sides, angle in between two sides, then right side. But these are not in proper order. This is side angle side, but this portion, this is angle side side. So these are not congruent. So this example is very simple. We'll do only the important and some tedious examples. The simple examples you can see. This is an important example. AB is a line segment. L is a perpendicular bisector. If P lies on L, show that P equidistant from A and B. It might be happen in the examination, you will not get the diagram. Simply you will get the question. So you draw this diagram and you have to prove that these are equidistant, P and PB. So simply we will prove these two triangles congruent by CPCT. These are equal. See, this is a quick revision. So we are doing orally. These two triangles are congruent. Perpendicular bisector. Perpendicular means these two angles are equal, and bisector means AC equal to CB, and this is common, PC. So by side angle side, these triangles are congruent. So by CPCT, corresponding parts of congruent triangle. If triangles are congruent, then remaining parts are equal. So PA equal to PB. Now next congruency criterion is angle side angle. Angle, this angle in proper order, side to this side, then again this angle to angle, angle side angle. See, angle side angle, and another criterion is angle angle side. Angle side, two triangles, this angle, angle, then side, angle side. So these are congruent by AAS. Prove that O is the midpoint of BC in this. So these triangles are congruent. We'll prove congruence, very simple. AAS. See, you can see ABO DCO equal alternate angle ABO. O is the midpoint of AD. O is the midpoint of AD means these two sides are equal. AO equal to BO. So by AAS triangles are congruent. Therefore, O is the midpoint of BC also, because OB equal to OC. Now this first question is very simple. Now let us see some important questions in this page. This fifth is very important question, and in fact third is also important. Now let us have a quick solution. See, in the question second, ABCD is quadrilateral. You have to prove that ABD BAC. So this is very simple. It is given that these two sides are equal. This is common, and these angles are equal. So by SAS triangles are congruent and the remaining parts are equal by CPCT. See, if you are not able to understand the quadrilateral, you can draw the diagram separately. In this way, you can do the good practice of geometry. See, these two triangles I have drawn separately. Now you can see this AD equal to BC given in the question, AD equal to BC, and this AB common, and this angle A equal to this B, it is given, angle DAB and CBA. So these two triangles are congruent by SAS. Now see the second question, CD bisect AB, means you have to prove this one, BO and AO. So these two triangles are congruent. You can see by this angle 90 degree and this part is equal. So which criterion of congruency? See, not SAS, AAS, because this is vertically opposite angle and these angles are 90 degree and this sides. These are angle side. AAS triangles are congruent, therefore this CO equal to OD. It means CD bisect AB. Again, this is very simple. These are parallel lines, vertical and horizontal. You have to prove that ABC, CDA. So remember again, student, don't wait for the full solution because I am giving only the quick revision. If you need the full solution, you can go to my channel and find out playlist class 9th maths. Now see, these are parallel lines. So these two are alternate angles and these two are again alternate angles, and this AC is common. So by ASA, angle side angle, triangles are congruent. On this question it is given L is a bisector. Bisector means these two angles are equal. This is 90. So this angle equals 90 and these are bisectors. So these two angles equal and this AB is common. So by AS triangles are congruent. So rest of the parts will be equal by CPCT. Now listen student, this sixth question is very important. A very simple question. Students find somehow tedious this figure, but you can see, you concentrate, you will find very easy. See, you have to prove that BC equal to DE. BC, this BC equal to DE. So you target the triangle. BC is a part of ABC. BC is a part of ABC and DE is a part of ADE. So our target is triangle ABC, ADE. AC equal to AE. Okay student, this AC you can see in this here, AC equal to AE. You can see in figure as well as here, AC, double click, AE, double click, and single AB equal to AD are equal. You can see here, AB equal to AD and this AC equal to AE. Now angles are given, this two. So these two are not a parts of this triangle. So we'll do one thing. We'll suppose this X, this angle, small angle X. We'll add this angle X both sides, here and here. So this will become BAC and DAE. So the triangles are congruent by SAS. So by CPCT, this BC equal to DE. So I am drawing the figure here separately. So we added this one. Now we reform this triangle. These angles are equal and this sides are equal. AB equal to AD and this AC equal to this AE. So by SAS triangles are congruent. Next question, this is also important but very easy. You can see DAP, our target is DAP and EBP, these triangles congruent. So here also we'll consider this angle X, we'll add it here, this side and this side. So this become this angle APD and X will also add it here. So this will become EPB. So this triangle will be congruent and P is a midpoint. This AP equal to PB, these are given equal. So by angle side angle congruent, triangles are congruent. The rest of the parts are equal by CPCT. This question is very easy. So you can see the very simple solution. I have already explained because it will take a time. So we are having the quick revision. Come to the next page. 7.2. It's very simple. Angle opposite to equal sides on isosceles triangles are equal. Sides are equal, then angles are equal. It has been proved by SAS. The very simple solution. Conversely, this is the converse of theorem 7.3. The sides opposite to equal angles are equal. Sides equal हैं तो angles भी equal होंगे. Now see, this example is very important. Example 4th. This is a bisector. Angles are equal and this is perpendicular also. We have to prove that ABC's isosceles triangle. Means isosceles triangle means we have to prove that the sides are equal by CPCT. Our triangles are this ADP, ADB and ADC. See, very simple. These angles are equal, this side common, these angles are equal. By SAS, triangles are congruent. So by CPCT, AB equal to AC. This fifth is also very simple. Now come to the sixth. Very important question. See, in this question it is given that AB equal to AC, D and E are points, and BE equal to CD. This BE equal to this CE. We need to prove that ABD and AC triangles are congruent. These two triangles are congruent. So very simple. From these two we will subtract DE. Listen, it is given in short. I am writing here BE equal to CD. So from BE we subtract DE. From CD also we subtract DE. So BE minus DE, it is BD. And CD minus DE, it is EC. Therefore BD equal to CE. BD and CE are the parts of these two triangles. So therefore these two triangles are congruent. Now I am drawing these target triangles, smaller triangles ABD and ACE. In this way, this BD equal to CE. And triangle ABC were isosceles. So these two triangles are these two sides are equal. AB equal to AC. Sides are equal. So the angles are also equal. Isosceles triangle. This B equal to C. So these triangles are congruent. SAS. Therefore AD equal to AE. So this is our target. AD equal to AE by CPCT. These questions also very simple. And the fifth question, a lot of students having some doubts because they used to do by congruency, but it will not by congruency. Listen here. These two are isosceles triangle. These are equal and these sides are equal. We have to prove that ABD whole angle this and ACD equal. See, very simple. These two sides are equal. So this angle 1 and 2 are equal. And these two sides are equal. So therefore this 3 equal to 4. So 1 equal to 2 and 3 equal to 4. So we will add it 1 plus 3. 1 plus 3 means this ABD. 2 plus 4 means ACD are equal without congruency. Some question might be asked without congruency, only your concept should be clear. Now see, question number 6 is most important, and 7th and 8th are very easy. But see the question 6. ABC isosceles triangle AB equal to AC and BA is produced. AD equal to AB. This AD equal to AB. We need to prove that BCD is right angle. Sometimes it asks that find the value of BCD. It is given that AB equal to AC and AB equal to AD. This pair shows that AB is common, so therefore AC equal to AD. So it means these two angles are equal. This 1 equal to 2 isosceles property and this 3 equal to 4. Now listen here students. 1 equal to 2 and this we'll write reverse 4 equal to 3. Now add it 1 plus 4 equal to 2 plus 3. Now listen students, we'll add the BCD both sides. 1 4 BCD. See here 1 4 and this BCD. This is BCD. By angle sum property it will be 180. And 2 plus 3 plus BCD means twice of BCD. So BCD will be 90 degree. Now next congruency criterion SSS, side side side. See, in polygon, if all sides are equal, they can cover to each other. These are congruent. This triangle, you can see this purple equal to purple, this blue equal to blue, green equal to green. So these are congruent by SSS. Now the very important criterion RHS. In a simpler words, we can state in a two triangles, if one angle is 90 degree and one hypotenuse equal and any of the sides, corresponding side, listen. This perpendicular to perpendicular, hypotenuse to hypotenuse, 90 to 90. So these are congruent by RHS. RHS. right angle hypotenuse side. You already get this confusion. Sometimes student get confused. Hypotenuse equal, this 90 equal, and this side equal to this side. So these are not congruent. Perpendicular to perpendicular, hypotenuse to hypotenuse. In all, let us recapitulate first of all SSS, SAS, ASA, RHS. But remember that SSA is not possible. So do not use the SSA. If any triangle, two sides and one angle are equal in order, so do not use SSA. Is not possible. This side, this side, this side, this side, and this angle. It is not a congruent. Also remember that if in two triangles 90 degree, so it is not necessary always the RHS. Suppose this perpendicular equal to perpendicular, base equal to base, so this is SAS because hypotenuse is not here. And also if 90 90 and hypotenuse and this angle equal to this angle, then no RHS, it will be AAS. This example 7, very simple solution given. This example 8 is also important. P is a point equidistance from lines L intersecting. Show that AP bisect angle between them. Diagram is not given, so you try to draw the diagram yourself first. I am showing here. See, this is a diagram. LM are intersecting here. You have to prove that this is bisecting, means PAB equal to PAC. So in these two triangles, you can see it's very easy. By RHS, prove it 90 90. This is common, and PBA equal to PAC. This is 90. PB equal to PC. It is also given. I drawn the two separate triangles. This PA equal to PB, PA equal to PB equal to PC. It is given in this diagram. You can see this PA common, and this PB equal to PC given, and this is 90 degree. So triangles are congruent by RHS. Why RHS? Because side, hypotenuse and 90 degree. So PAB equal to PAC. This angle are equal by CPCT. So it means this bisect these two intersecting lines. Now in this 7.3, first is very simple, second simple, third question is important. Third question, it is asked ABM PQN. The sides are given equal. BC, this AB and BC, the AB full, this BC full, not this part, BC equal to this PQ full and this QR full. You should remember median means the line which bisect the triangle. This is a median property. So this bisect, so these two are equal, these two are equal. Since this BC equal to this QR, therefore this part BM equal to QN, and this is already given equal, and this median is also equal. So these two triangles are congruent by SSS. Now what about this part ABC PQR? See, since these two triangles are congruent, so by CPCT this B equal to Q. This angle B equal to Q by CPCT of this part. These two triangles are congruent, smaller. So B and Q are the parts of this triangle. So B and Q angles are equal. Now see, in a whole triangle ABC and PQR, without median I am drawing here to make it simpler. This is given AB equal to PQ and this BC equal to QR. It is given. Just now we proved that this B equal to Q. So it means this B equal to this Q. CPCT of this portion ABM and PQN. So these two triangles are congruent by side angle side SAS. Now see, this fourth question is also important. B and CF are two equal altitudes of triangle ABC. Using RHS prove that ABC is isosceles. BE and CF are equal and this is 90 degree and BC is common. So the triangles are congruent by RHS. See, BE, CF equal altitudes. BC, BC you can see common, and this is 90 degree. This E and F are 90 degree. So the triangles are congruent by RHS. Triangles are congruent by RHS. Therefore, angle B equal to angle C. In this figure, see here, angle B equal to C. Therefore, triangle ABC is isosceles triangle. So class 9, these were the basic concept and some important question. If you are having the doubt, you can write in the comment box. Thank you.